Okay, so welcome to your very first grade 9 math lesson. We're gonna go over number sense. So a lot of this you know already from grade 8. So since it's the first class, we'll go easy. We'll just refresh our memory of what the different type of numbers are. So can anybody tell me what are natural numbers? Natural numbers, Max. No, just give me examples. Positive whole numbers. Good. I like that definition. Okay. So what distinguish between whole numbers and natural numbers then? You said the key word is not negative, but you know how you said natural numbers are positive whole numbers? That is technically the correct answer because you said positive. All right. So if you take a look here, natural numbers are 1, 2, 3, 4, 5. So the counting numbers. Okay, all positive counting numbers. So if you take a look at this list and this list, what's the difference between whole and natural then? Zero, that's right. So that's the only difference. Whole numbers have zero. Okay, and then what about integers? If you take a look at this list of numbers with this list of numbers, Bukan. All whole negative and positive numbers. Perfect. Okay, so also include negatives. Okay, and then so these three are pretty easy to distinguish. So rational and irrational, these two are the ones that are a little bit more challenging, these two. Okay. For rational numbers, they are numbers that can be expressed as integers. So for example, 2 and 3, these are integers, and you can write it as a fraction. That means it's a rational number. It could be positive, it could be negative. 5 is a natural number, but it's also a rational because we can put it as 5 over 1. Right? 1.25. This is a decimal, but if anybody know what is 1.25 as a fraction? 5 over 4. Excellent. So 1.25 is the same as 5 over 4. And because I can write it as a fraction of integers, it means it's a rational. Right? So you can also have decimals as rational numbers. So Miss, how do I know what decimal is rational and what decimal are irrational? So if it's a decimal that ends, you can always write it as a fraction. So this, even 0.457, that's a terminating decimal. So a decimal that ends is a rational. On the other hand, you can have decimals that repeats. Okay, so here 66, which means this is 1 and 2/3, right? Or 5 over 3. So that's rational. You have this decimal that keeps repeating 2567, 2567, 2567. So this repeating part right here, if it repeats, it also represents a rational. Right? What's a famous irrational example? For irrational, yep. A number that goes on forever. Pi. Good job. So pi, this is the most common one. If I on your first test, I'll probably ask you what is an example of an irrational number. So that one should be like a given framework. All right, pi is a decimal that goes on forever. There's no pattern. That's an irrational number. By the way, how many? What's the number for pi? Something. Okay, how many decimal can you remember? I can remember 5. 3.1415. That's it for me. You can do 7. Okay. One of my students in my semester 1 class was able to do, I think, 15 digits. That was Eric, right? Yeah. Yes. So, do you need to memorize all those? No. Oh, okay. So, in Sophia wants to challenge it.
No, I'm okay. I can only memorize like 12.
Only. Okay, let's hear it.
3.1415965358979323846264.
Okay, well, guess what? None of us can certify if you were right or wrong. So, we'll give you the benefit of the doubt. We'll say that you were right. Good job. That sounded very impressive already. Okay, so all these numbers right here, this is considered all real numbers. All right, so this is a really nice diagram to help you remember what's what. Okay, so remember, natural numbers are counting numbers, and whole numbers is all natural numbers including 0, right? So that's why this circle is inside the whole number circle. All right, and then so that means all natural and whole numbers are also integers. Okay, and all natural whole numbers and integers are also rational numbers. Right? So let me ask a quick question. Let's say the number 5. Okay, is the number 5 a natural number? Is it also a whole number? Is it also an integer?
Yes.
Is it also a rational?
Yes.
Is it also a irrational? No, because it's outside the circle. Okay, what about -5 now? -5, is that a natural? No. Is it a whole? No, negative. Negative is not a whole. Is it an integer? Yes. Is it a rational then?
Yes.
Yes, because the integer circle is within the rational circle. So if it's in here, if it's in this circle, it means it's in everything else. If it's only in here, then it means it's it's a integer and a rational, but not a natural or whole, because it's outside of that circle. Okay. We'll do some examples together. So, but this is a nice diagram to help you remember what is what. R stands for the real number system. So everything here is in the real number system. There is actually an outside circle. If this is real, what is this circle? Fake. E-real. Okay. I like the creativity. Right? But when you say fake, it doesn't sound very mathematical. It sounds too fake. Any term that sounds fancier? If it's not real, what type of number is it? Sophia? Imaginary. See how much more it's imaginary. See how much more fancier it sounds than fake? Alright. The good thing though, the good thing of imaginary numbers is you don't have to deal with it until grade 11. Yes. Example, square root -1. Because can you square root a negative number? No. So that's why it's called imaginary. Why do you imagine numbers? I don't know. That's undefined, but not imaginary. Alright, so imaginary numbers, real numbers. So the good thing is in grade 9, we only deal with the real stuff. Okay, so let's try these ones right here. 4.5. 4.5. 4.5, where does it go? Which part of the circle will it go? Is 4.5 an n? Nope. Is 4.5 a whole? Is it 4.5 an integer? Nope. Is 4.5 a rational? Yes. So it's a rational. And what else? Huh? Rational, and all numbers belong to real. Good job. I love the participation from Max. All right. All right. All of these are real. All right. So, what about -3/8? Who has the answer to that one? What type of number is that? -3/8. Other than Max, I already know that he's really good with participation. Alvin, also rational. And if it's a rational, it's also real. Good. Okay. 25. 25. What type of number is 25? Margaret? Natural. And because it's a natural, that means it's also
Integer.
uh-huh. And
Rational.
right. Okay. So all of them, because it's in the smallest circle, right? As soon as it's in the smallest circle, that means it's everything. Yeah, we use the letter Q for rational. I can totally see the spelling of Q in this.
Q with a dash on.
Irrational is a Q with a dash on top. So out of the 26 alphabet, they didn't like any of the 26 alphabets, so they decided to put a line on top of it. Okay, 0. What type of number is 0? Okay, let's put up our hand. Okay, but thank you. Yep, whole number, integer, rational, and real. Yeah, so be careful. This R represents real number, not rational. Okay. Yeah, sometimes math is confusing, and especially confusing when they don't know how to use the alphabets. Okay. E, square root of 4. Okay, Sophia.
Natural, whole, integer, rational, and real.
Good. But I thought, Miss, didn't you say square root number is like irrational? So Max, what did you say square root 4 is? It equals 2. Yeah, so now, since it's 2, it's a natural. So it's actually this. So even doubt, use your calculator, square root 4, to see if you get an integer, if you get a natural, or if you get a decimal. Okay. So on the other hand, square root 6. Let's see, somebody who's been quiet. Square root 6. So Yun, what do you think? No, pass. Okay. Hussein. Okay, pass. Angelina. Irrational. Because when you do square root of 6 on a calculator, square root of 6, you get this. Is there any pattern? Nope. Okay. Your calculator only takes 10 digits because otherwise you'll have a like really big calculator. Yeah, so it doesn't stop and it goes on forever. There's no pattern. So I know it's a irrational. Okay. It's a irrational and what else? Real. It's still real. Okay. Okay, so 2.111111111. It repeats. Okay, so sorry? It has a pattern. Yeah, that's right. So if it repeats, it has a pattern, then it is a rational and real. Okay. 2.1. It doesn't repeat, but it terminates. It stops. Furkan?
Rational.
Yeah, good job. Right? So again, here, terminating or repeats. That means it's a rational. All right. This one is a tricky one. 1.01, 001, 0001, 0000001. Irrational. Good job. Okay. Yes, I see a pattern, but does it say anything here about patterns? No, it's repeating, and pattern is different. All right. Repeating means like the exact numbers repeated. Pattern, the exact numbers are not repeating. I see a pattern, but I don't care about patterns. Okay, this one we were talking about it earlier. So you want to give this one a try? Pi. Sorry, say that again. Irrational. Perfect. Good job. Irrational. And then last one, negative 780. Negative. So the fact that it's negative, I know already it's not natural, it's not whole. So Alvin, integer. And if it's an integer, it is an rational, right? Okay. So, well, there you go. 16-minute lesson. I told you it's under 20 minutes.